So get this, a collaborative team from Meta, Google DeepMind, Amazon, Yale, and a bunch of others just published a roadmap for a whole new era in AI. We are moving from chatbots that simply talk to autonomous agents that can plan, act, and most importantly, learn from their own failures. Today, we're unpacking how our glorified autocomplete engines are going from passive predictors to think, act machines. And oh, it isn't magic. Let's look at the board.
Let's just break that down for a second. For the longest time, we've been using large language models that are, fantastic at predicting the next word. You give them a prompt, they give you a response. It's basically the world's most sophisticated autocomplete. But what we're seeing now, it's a total shift. We're moving to systems that don't just predict, they act. They can make a plan, carry it out, and the real kicker, they learn from their own failures so they get better over time.
And look, this isn't some fringe idea coming from a garage somewhere. We're talking about the heavy hitters here. Meta, Google DeepMind, Amazon, and top-tier universities like Yale. So you got to understand, when these guys all get together on something, it's not just another research paper. It's basically a giant signpost for where the entire industry is heading. So yeah, we should probably pay attention.
Okay, so to really get our heads around this, here's how we're going to break it down. First up, we'll talk about that huge leap from autocomplete to agents. Then, we'll peek under the hood at the Think Act secret sauce. After that, we'll see how these agents actually do stuff and get smarter. Then we'll scale up to see how they play in teams, check out the real-world impact. And finally, we'll ask the really big question: what does this all mean for us?
All right, first up, the paradigm shift. And this is absolutely foundational. We have to get this part right. We are literally leaving the world of passive word prediction and walking into a brand new world of interactive problem solving. It's a whole new ballgame, and it's tackling the single biggest weakness of the models we use today. So check out this table. It lays out the difference perfectly. On one side, you've got your traditional LLM. Think of it as passive. It works in a single pass, so it gets one shot to answer you. And it kind of forgets everything once you move on. It's just reacting. But an agent? Totally different story. It's interactive. It works in this multi-step loop, constantly getting feedback. It can use external memory, and it's built from the ground up to keep improving itself. You see the difference? It's not just reacting to you anymore. It's actively, relentlessly trying to achieve a goal. And this all leads to the official term they use in the paper, agentic reasoning. The key here is that reasoning isn't just one of its skills anymore. No, it's this central organizing principle. It's the boss, the CEO. Everything the agent does, seeing the world, planning its move, making a decision, checking its own work, it's all driven by this core reasoning engine. It's the conductor of the entire orchestra.
Okay, so that's the what. But how? How does a model go from just spitting out words to actually thinking and then doing stuff? Let's go inside the agent's brain and find that secret sauce.
The big idea here is actually kind of simple, but it is so powerful. Basically, an agent won't do anything, anything in the outside world, like calling an API, until it's worked out the logic on its own internal scratchpad first. It's just like doing a math problem. You don't just shout out the first answer that pops in your head, right? You work it out on paper first. That's exactly what's happening here.
Now, in the paper, they call this hidden scratchpad the latent variable, or just Z. The easiest way to think about it is it's the agent's internal monologue. It's that little voice in its head. This is that critical, wait, let me think moment that separates a wild guess from a thought-out, considered action. It's this private mental space where the agent can game out a plan before it commits to doing anything.
So this whole process breaks down into two distinct steps. Step one is all internal thought. That's what they call pi reason. The agent is just thinking on its scratchpad. And only when it's done thinking does it move to step two, taking an action in the real world, pi x. And this is the whole game. The action is based on the thought. This separation is how we go from AI that's just running on pure vibes and statistics to AI that delivers grounded, verifiable results.
Okay, so we get the think-act loop. That's cool. But what can these agents actually do? And maybe more importantly, how do they get smarter? Let's dig into the foundational skills and that all-important growth loop.
It really boils down to three foundational abilities. First, there's planning. Taking a huge goal, like plan my vacation to Tokyo, and breaking it into tiny, doable steps. Second, tool use. Now, the best analogy here is to imagine an LLM is like a brilliant, but let's say overconfident new hire. They're so smart they might just make up a number instead of admitting they don't know. Giving an agent tools, like a calculator or an API, is like telling that new hire,
Hey, it's not just okay to use a calculator, we demand you use it. It keeps them honest. And third, agentic search. This isn't your standard Google search. It's way more dynamic. The agent searches, looks at the results, and then decides, is this enough? Or do I need to dig deeper before it even thinks about giving you an answer? All right, I know this diagram looks complicated, but it actually pulls together everything we've just talked about. Over here on the left, you've got those core skills we just mentioned: planning, tools, search. And on the right, that's the magic loop. You see the feedback, the memory, how it's all designed to just keep getting better. The key takeaway here is that it's not a one-way street. It's a cycle. It's designed to constantly improve.
And honestly, this brings us to what I think is the most mind-blowing part of all of this. Because you see, a truly intelligent system, it can't just be a static program. It can't be just a script. It has to be a student. It has to fail, and it has to know it failed, and then it has to learn from that failure. That's where real intelligence comes from. And the paper points to 3 incredible ways these agents actually evolve. First is verbal. The agent literally writes down notes to itself like, I failed because I used the wrong API key, storing reflections on its own mistakes. Then there's procedural. It basically builds a library of new skills. A famous example is the Voyager agent. It literally learns how to mine for diamonds in Minecraft, then save that code as a new skill it could use whenever it wanted. And then there's the really wild sci-fi stuff, structural evolution. This is where the agent uses an LLM to, get this, rewrite its own code. It's like a car that's also its own mechanic, constantly tinkering with its own engine to get better. So a single agent that can learn is amazing, no doubt. But to solve truly complex, real-world problems, a solo act isn't enough. You need a full orchestra, and that's where multi-agent systems come in. And this image really nails the concept. Instead of having one super smart agent trying to do everything, you create a team of specialists. One agent might be the project manager, another one is the coder, another one is the QA tester. You get the idea. They work together to tackle problems that no single agent could solve alone. And we're already seeing some classic roles emerge in these AI teams. You have the manager agent, who's the planner, breaking down the big goal. You have the worker agents, who are the specialists, the doers. And this one is so important. You have the critic agent. Its only job is to check the work, find mistakes, and send it back for revisions. This whole setup, it just dramatically boosts the quality of the work. And in these big, complex teams, you know what turns out to be the best strategy? Honesty. This was proven by Meta's CICIRO agent, built to play the game diplomacy, which is all about negotiation and betrayal. They found that, in the long run, lying is just too much work. It's too computationally expensive once you lose trust. So, honesty, it's basically a strategic hack for being more efficient. Okay, this stuff is all super cool in theory, right? But what does it actually mean for the real world? Let's look at where the rubber is already meeting the road. We're already seeing this stuff in action. In robotics, you can give a high-level command like, clean the kitchen, and the agent figures out all the tiny little motor skills to make it happen. In healthcare, you have these diagnostic assistants that can sift through mountains of patient records to find patterns a human doctor might miss. And in research, they can surf the live web, pulling info from all over to give you a comprehensive answer. But the real frontiers are even crazier. Think about agents that can work on a problem for weeks, and the huge question of how we even govern these things. And that brings us to the final and, maybe the most important question of all. In a world with autonomous agents that can plan, act, and learn, what's left for us? I mean, really think about it. If these agents can set their own goals and learn from their own failures, getting smarter every single day, what's left for us to do? What's the human edge? Well, the answer, in a world of pure automated logic, is that our most valuable skills become things like judgment and empathy. The agent can tell you the most efficient way to do something, but it can't tell you the right way. That takes human judgment. That takes empathy. We provide the why. Look, this tech isn't some finished product being handed to us. It's more like a new medium, like a blank canvas. The chalkboard is clean, and now it's our turn to decide what we're going to draw. If you want to stay on top of this stuff, and trust me, it's moving fast, make sure you subscribe to CasiornThinks on YouTube and on your favorite podcast app. You can also follow us on X and Facebook, we're at CasiornThinks, and check out our deep dives at CasiornThinks.blog. So I want to leave you with a question. What's one job or task you believe could be completely revolutionized by a team of AI agents? Drop your thoughts in the comments below. We'd love to read them.
Thanks for watching.